What's
Right.
interesting is as the rates of people being diagnosed with autism have gone up, the rates of people being diagnosed with just intellectual disability, or what in the States used to be called mental retardation, are going down. And the
Wow.
reason is that people who used to be called mentally retarded are now being called autistic. Right? So there's a
Huh.
substitution of one diagnosis for another, which just doesn't fit at all with the idea of some kind of an epidemic
Right.
where, the idea of an epidemic almost screams out that there must be some cause in the environment. There must be something causing it out there in the world that's affecting our kids and making them.
Well, it's like that funny saying, like everything is conspiracy if you don't understand how anything works.
Yeah. I mean, yeah, it's like in this case, it's actually understandable given the data, right? If you
Right.
just look at the prevalence and you say that's a prevalence of disease as opposed to a prevalence of diagnosis, right? If you make that
Right.
mistake, which is very easy to make, it seems reasonable to say there must be some environmental cause, right? But there's no evidence for any environmental cause whatsoever. Like vaccines, for example, have been studied so much in millions and millions of kids, comparing the rates of autism in kids who were vaccinated to kids who weren't. And there's no difference. I mean, in millions of kids. So what there is very good evidence for is a genetic causation complex, right? So we know hundreds of different genes that mutations in those genes increase the risk of autism. And you could say the same thing for intellectual disability, for epilepsy, for inherited deafness, for inherited blindness. There's just a whole bunch of genetic conditions that manifest in different ways where we have been able as geneticists to track down different causes in different families. Okay, so there's not one gene, there's hundreds and hundreds of genes that can carry a mutation that increases the risk of autism. Now,
Right.
things get really complex here because those mutations tend to not just increase the risk of autism, but they also increase the risk of ADHD, of epilepsy, of even things like schizophrenia, depression, and so on. So there's a sort of a
Hmm.
general psychiatric risk that can come about. And most of these genes are genes that are involved in wiring the brain or putting basically brain development of some way. So the general idea is that, it takes thousands and thousands of different genes to put our brain together. It's an incredibly complicated system and the self-assembly of it is incredibly complicated. Mutations that affect any of those genes can alter brain development in ways that can manifest in one person as autism, in another person as epilepsy, in another person as ADHD, and so on. And you can
Right.
see that even in identical twins where, if one of them has autism, chances are very high, almost 80%, that the other one will also have autism, but they might not, right? So sometimes they don't, and sometimes they might have some other condition.
Right.
So the genetics is very complex, but we're learning more and more about it all the time. We're identifying more and more of these risk genes and the mutations in those genes that increase risk. Even within an individual, it's not just the effect of one gene. There's a genetic background. There might be multiple mutations. So
Hmm.
so it makes it a really messy story, hard to talk about, hard for us to
Sure.
understand, but still the overall picture is that by far, the majority of the risk for autism comes from genetic differences between people. Now,
Right.
that does leave a little bit
Hmm.
unexplained, where you might say, okay, so something like 80% of the variance in risk of autism is genetic in origin. But what about that other like 20%? What's that? And people often assume if it's not genes, it must be environment. Right? That's just a sort of a typical division that people make. But actually, there's a whole other source of variation that people overlook, which is just the process of development itself. So the genome is not like a blueprint that deterministically specifies the outcome of embryonic development. It's more like a recipe, actually, where there's all these sort of processes. It sets up some kind of biochemical rules, and the
Hmm.
way those rules play out then will determine the way your brain actually develops. So that's why, the brains of identical twins are very, very similar to each other, but they're not actually identical because
Right.
every time you run the program, there's a little bit of variation.